Hey guys, so I wanted to go back and pick up the last part of the note, scientific notation. So the application is these are really big or really small numbers. You see these a lot in science. So you can write any number in scientific notation, but typically we only have really big or really small numbers. You can see two examples there on the screen. The distance to the sun, that's a really big number, versus the mass of an electron, which because that decimal place is in front tells me that that's a really small number. The key here, highlight, underline if you haven't already, this is important. If numbers are really, really big, if they are greater than 1, you are going to have a positive exponent. If numbers are really small, so but like they're a decimal, like we see the mass of the electron, 0.000000 and so on, those exponents are going to be negative. With scientific notation, the trick is that I only want one number in front of the decimal. So let's look at some examples. The first one is 2,500,000. So this is a really big number. It's greater than 1. It's a large number, which means I'm going to have a positive exponent. Now to find the exponent, I put my decimal, so if I don't see one, it goes at the end, and I'm going to move that decimal until there is only one digit in front. So I'm going to move 1, 2, 3, 4, 5, 6 places. So because I moved 6 places, that is going to be my exponent, and because that's a big number, it's going to be positive. And then the number out front is going to be where I moved the decimal to. So 2.5 times 10 to the 6th. That is the same number written in scientific notation. So let's look at the next one. 0.0072. So this is a small number. It's a decimal. So my small numbers are going to have negative exponents. I'm going to move my decimal until there is only one digit in front of the decimal. So 1, 2, 3. If I stop right there, I only have a 7 in front of the decimal. The zeros don't really count in scientific notation. So I'm going to have 7.2 and then times 10. Well, because I moved it 3 places and it's a small number, that thing is going to be a negative 3. So I'll have 7.2 times 10 to the negative 3. Next example, really, really big. Now, we're looking at the absolute value of this because technically negative 470 billion is really, really small. But the absolute value is what I'm considering with positive or negative exponents. So I've got my decimal back here. I'm going to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spots. So I'm going to move 11 places, which means my exponent is going to be 11. Now we said it was positive because that number is, the absolute value of that is a really big number, 470 billion. It's not a decimal. Times, and then the number itself is going to be this thing, negative 4.7. And so in scientific notation, it's going to be negative 4.7 times 10 to the 11th. So that is moving from standard form to scientific notation. So now let's look at moving backwards. So I'm given scientific notation and I want to move into standard form. So I've got 5.6 times 10 to the 5. Well, because that 5 is positive, that means I need to make this number bigger. So because that is positive, that's going to tell me that this should be a big number. Well, my number, 5.6, if I move the decimal to the right, that number is going to get larger. So I'm going to move 1, 2, 3, 4, 5. fill in with zeros, and so my final answer will be 560,000. All right, the next one, negative 1.7 times 10 to the negative 3. All right, well, negative 3, because it is negative, that tells me that I need to make this number smaller. So because that's negative, I need to make that number smaller. Well, if I move this decimal to the left, that's going to make 1.7 smaller. So 1, 2, 3. I'm going to fill in with zeros. Now that negative sign, I am going to want to move all the way out front. I don't want it sticking in the middle of that. So my final answer would be negative 0.0017. Or you could write it as negative 0.0017. Either one of those would be correct. 3.1 times 10 to the negative 7. Again, because that thing is negative, I need to make this number smaller. So I need to move my decimal to the left 7 spots. So I'm going to rewrite it. 1, 2, 3, 4, 5, 6, 7. Fill in the zeros, and so my final answer would be that right there. Again, you could write a 0 in front if you wanted. All right, the last little piece is going to be operations with scientific notation. The thing to remember here is if you are multiplying, this is a rule we learned back in algebra. If you are multiplying exponents, you are going to add the exponents. If you're dividing exponents, you are going to subtract. And so that's going to come into play. You did this in Math 101, but depending on how long ago that was, you may not remember it. So if you're multiplying, you're going to add. If you are dividing, you're going to subtract. So let's look at our first example. 3 times 10 to the 12 times 2 times 10 to the 19. So I've got two scientific notations. All I'm going to do is just really reorder these things. I'm going to move the numbers up front. So I'm going to move the 3 times the 2. Okay, so I'm moving the numbers up front. And then I'm going to move the exponents into the back. So 10 to the 12, and then 10 to the 19. So I just rearranged it, which we've kind of seen that already before. Now I can multiply like I'm used to. So 3 times 2 is going to give me 6. I've got big bases being multiplied, so the property says that I can add the exponents and keep the base. You learned that property back in Math 101. You saw it again in Math 102. You saw it in Math 110. So you've seen this before. I'm going to add 12 plus 19, which is going to give me 31. And so that's going to be the exponent on the 10. So I'll have 6 times 10 to the 31. Okay, second example is now I've got numbers being divided. So it's going to follow the same idea. 24 times 10 to the 24th divided by 3 times 10 to the 17th. So I'm going to rearrange, put all my numbers up front. Now before, when I rearranged, I multiplied them, but because these are being divided, I'm going to have 24 divided by 3. So when I rearrange them, I'm going to have to rearrange the division sign as well. Same thing with the 24, or sorry, the 10 to the 24th. So I've got 10 to the 24 divided by 10 to the 17th. So 10 to the 24 divided by 10 to the 17th. So I do have to carry that division. Now between these two is multiplication, but you can kind of think about it as distributing. I've got divide by 3, divide by 10 to the 17th, if you want to kind of think about it like that. All right, so now I'm going to work with each individual piece. So I've got 24 divided by 3 is going to give me 8 times. Here, 10 to the 24th divided by 10 to the 17th, because they are being divided, how did I write it before? I'm going to, because they're being divided, I'm going to subtract the exponents and keep the base. And this is called the quotient rule, if you're thinking back to your algebra days. So 24 minus 17 gives me 7. And so my final answer will be 8 times 10 to the 7th. All right, the last one, we're going to kind of make it a little more complicated. We're going to do 3 different operations. Now think back to your order of operations. Order of operations says that when you have multiplication and division, you move from left to right. So we're actually going to do this piece first, and then we'll divide it. So we're just going to solve those first 2 parentheses, and I'm going to do them the same way. I'm going to rearrange, put the numbers up front. So I've got 3 times 8. Move those up front, and then I'm going to take care of the exponents. 10 to the 12th, 10 to the 19th, 10 to the 12th, 10 to the 19th. Multiply 3 times 8, which is going to give me 24. And then because these 2 exponents are being multiplied, I am going to add 12 plus 19, which is going to give me 31. Now that I've done that first part that I highlighted in a box, I'm going to bring down that whole thing. And now I'm going to do another problem. So now I've got divide by 4 times 10 to the 12th. So now I'm going to work a second problem. I'm going to rearrange just like before, bring the numbers up front. So I've got 24 divide by 4. Because I'm doing, because I'm doing division, I'm going to do next, sorry, I'm trying to pick colors, the exponents. And so I've got times 10 to the 31 divide by 10 to the 12. So again, I'm just rearranging, and now I'm going to simplify each piece. So 24 divided by 4 is going to give me 6 times. These 2 numbers are being multiplied, or sorry, these 2 numbers are being divided, so I'm going to subtract the exponents. So 31 minus 12 is going to give me 19. So I'll have 6 times 10 to the 19. And so that would be your final answer.